Hi everyone, Lando Asisten here, and here is our math problem for today. What is the value of this expression containing the imaginary number I? The expression is the quantity 1 plus I square root of 3 all over 2 raised to 7,777. Now let's solve this problem together. Let's begin by letting x be equal to the base of this exponential number. So x is equal to 1 plus I square root of 3 divided by 2. Then let's multiply both sides of the equation by 2 to eliminate the denominator, and this is the result. And then let's subtract 1 from both sides of the equation to isolate the expression with the imaginary number I. And since there's a radical here, let's square both sides of the equation, and here is what we have. Now, let's remember this value of x. We're going to go back to this later on. Now, let's expand this binomial at the left. This is the result. And at the right side, raise that to exponent number 2. So we have I squared, which is equal to negative 1. And the square root of 3 squared is equal to positive 3. Now, the right side is equal to negative 3. And we add 3 to both sides of the equation. And simplifying, we now have this quadratic equation. Now, 4 is common among these three terms. So let's divide by 4 to arrive at this simplified quadratic equation. And let's solve this for x squared. X squared is equal to x minus 1. Now, at this point, let's multiply both sides of the equation by x. And let's simplify. Let's remember this value of x squared because we are going to go back to this later on also. So the left side becomes x cubed, and we distribute x to the binomial x minus 1 to arrive at this. But notice that we have here an x squared and we have here an x squared. So by substitution, we can substitute x minus 1 for x squared, and we have this result. Now in here, this x squared is now this x minus 1. Now notice that we have here x minus x. So the right side is simplified as negative 1. So what's left is x cubed equals negative 1. Now let's go back to the original problem. We know that this base 1 plus I square root of 3 over 2, we let that to be equal to x. So we can replace this base by x to have x raised to the exponent 7,777. Now we have here an expression in terms of exponent 3. So let's re-express this exponent 7,777 as 3 times 2,592 plus 1. And therefore, we now have this result. We now write this as x raised to 3 times 2,592 plus 1, which is this original 7,777. Then let's recall some properties of exponent. Let's remember that when you have here the sum of exponent, that can be written as the base raised to the first addend times the same base raised to the second addend. And so this is now the result. So we have x raised to this exponent and the same base x raised to 1. So we did not write the 1 here anymore. Then let's recall one more property of exponent in order to deal with this part. So that property is the power of a power rule. So we have here in the form the base raised to a product. So the base raised to a product, that can be written as the base raised to one of the factors all raised to the second factor. So we can now rewrite this as x to the third raised to 2,592. Just copy the other x. But we know what's the value of this x cubed. We know that the value of x cubed is equal to negative 1. So we can now replace this x cubed by negative 1. And this is what we have. Negative 1 raised to this exponent and then copy x. Now let's deal with this negative 1 raised to an even number exponent. So when negative 1 is raised to an even number of exponent, the result would be positive 1, and we just copy x. And therefore, this original expression is simply equal to x. And so this is now our result. But what is the value of x? We said that the value of x is this complex number. So if the original expression is equal to x, and x is equal to this complex number, then by transitive property, we now know what's the value of our original expression. And therefore, we now have the answer. The value of the quantity 1 plus I square root of 3 all over 2 raised to 7,777 is equal to 1 plus I square root of 3 all over 2. There are other ways of solving this. We can also solve this using the Euler formula and some other complex analysis methods. If you have other method of solving this problem, you may want to share in our comment section. So thank you very much. This is Lando Asisten. We hope to see you again in our next video. Bye for now.